when people overbuzz AI, I ask them, it's like, okay, what did AI change in your life? What did AI change, really, truly? Something. Don't tell me like you set a timer on Alexa or Google Home. Okay, that's not a life changing. So what was life changing? That came from AI, right?
You're listening to Gradient Descent, a show about machine learning in the real world, and I'm your host, Lucas Bewald.
Jerome Pesenti was VP of AI at Meta, which is one of the most exciting places where AI research is happening. Before that, he was CEO of Benevolent AI, and before that, he was VP of machine learning at IBM Watson. So he's had a long career and seen a ton of different applications and lots of change in the state of the art in machine learning. This is a super fun conversation, and I hope you enjoy it. The first question that's like top of mind is just with all the advances in, large language models that, we keep seeing. I know, Meta had BlenderBot, right? I was kind of wondering if you have like a point of view, or, Meta had a point of view on building a large language model like differently than, like a DeepMind or an OpenAI, and how you think about that.
Oh wow, you go right deep into the the challenge there. I mean, I would say the large, transformer models. I think at this point, it's not just language model, right? So the transformer large models are starting to really and having, being able to be used in multiple tasks. So I think this is a trend that everybody is following. Size, multimodality, more data, more self-supervision actually, and less, classical supervision. And then, rather trying to do multiple tasks at the same time. I think this is working really well. That's what people call them foundational model. I'm not sure I agree with that term, but so I do think, everybody's going in that direction, and that's, paying out handsomely. Where I would say I'm a little bit more cautious is I think these models have lots of problems, okay? And solving these problems is not trivial, it's not easy. I would say there's two obvious class of problems I've seen, and so the people will be able to solve that really will be onto something very interesting. One is control, So when you have this language model, I don't know how much you've played with like Stable Diffusion or GPT-3, it's really, really surprising in the things it gives you, but sometimes it really doesn't give you what you want at all, not necessarily what you ask. Sometimes it has big artifacts that show that it's not humanly generated. And it's not quite clear how you get rid of all this. You can there's this whole thing around prompt crafting. I think it's interesting, okay, but I don't think you can. It's kind of scary to say you're going to do this going to be a new type of software engineering is going to be because it's so unreliable, And so that's the first piece, which is how do you make all these models more controllable, which is you have a higher guarantee of what the outcome is going to be. And the second is bias. Obviously, intelligence is about bias, but if you type, something, the easiest way to do it is on this new image generation models. If you type CEO, guess what you get? If you type assistant, guess what you get? If you type fast food worker, or if you type, banker, it's striking. It works, 100% of the time, you get extreme bias. And it means you can't really just use this in production. I think it would be terrible. So very exciting. I think everybody's seeing the trend there. It's working, scale, multimodality, multitask, self-supervision, but, they are not very controllable, and they have huge, bias issues.
Do you feel like there are still intrinsic cognitive limitations, like a Gary Marcus might say on Twitter? How where do you sort of stand on the promise of this technique with transformers?
I'm definitely you have the spectrum of Gary Marcus on the left, and you have, I think, the people who are extremely enthusiastic talking about AGI on the right. I'm squarely in the middle. Okay.
Oh no, this is going to be a boring interview.
Yes. I can tell you some things that are very, controversial. So, so no, I think Gary really overdoes it, because the progress is undeniable. I mean, everybody seeing these systems is surprised. I mean, I've been in this space for more than 20 years, and I look at the stuff and I'm blown away, you know.
Yeah, totally.
And you had asked me a year ago, would we have made this progress? And I wouldn't have guessed it. I thought that these tasks were higher. But I think what happened is that the more you get closer to like human level intelligence, the more you realize that the task is much harder. And so some people are like, oh my God, we're going to lose our job as developers or as creators. No way that's going to happen. I mean, like, we're still millions, you know, like away, because as soon as you make some progress, you realize that, you know, and it's some people have said, but it is that the goalpost actually looks further, because you realize actual intelligence is a much wider space. It's much more complicated. So you realize that the system still makes very, very silly mistakes that humans wouldn't make, but it does things that you didn't think would be possible. So I am squarely in the middle, which is I don't think we are anywhere close to human intelligence. I also think that AGI is a bullshit term. It doesn't mean anything, because intelligence is by definition never general. And then I don't buy Gary, because look, you can deny the progress. It's like you look a little bit like a fool if you deny that. But you know, it's such a much bigger problem than people imagine. So as we said at Meta Facebook, you know, we're 1% down, and I really believe it. We're 1% down, but we did go 1% out of the way, and you know, and that's a huge accomplishment.
1% what?
1% to human intelligence. You know, so we made progress.
Right.
We made real progress, right? But it's such a, you know, intelligence is so amazing that you still have a long way to go.
But don't you feel like the stuff that we're building is starting to help building, yeah, the next generation of that stuff? Like I kind of can't believe how well the code generation works. Like I've been using it.
That one is also super overstated. I mean,
you think so?
I mean, absolutely, because I mean, you are in software, right? I mean, like I give you a piece of code, okay, and I tell you it's 99% accurate. How good does it give you? Like the problem is that generating code that's not accurate. I mean, sometimes finding a bug is way harder than writing the code from scratch, right? So
that's fair.
I think the way to think of codecs and stuff like that is like an autocomplete, right? Mm-hmm. It's a very smart autocomplete, the same way when you write your email right now, Gmail does autocomplete, and it can complete sentences, and it's quite smart and it's quite impressive. And if you cherry pick the results, it looks amazing, and it's very surprising what it can do. But you know, like it writes something, and then you have to say like, well, is it actually accurate? You don't have guarantees. You know, and not having guarantees in code is a huge problem, right? I mean, like, you know, really bug-free code is worth 1,000,000 times code, right? I mean, it's not the size of the code that matters. So I'm really cautious on this one. I do think it's a useful developer tool. You know, people will use it, like they use autocomplete to write email, but it's not going to put developers out of a job. No way. And especially it's very, you know, it's tricky when you write code, because, you know, you need to have guarantees.
Well, I certainly feel like it helps me write code faster. So I like imagine like better versions of it, you know, it seems very far from making, you know, putting someone out of a job, but it seems like it could make people more productive.
Faster, but is it better or is it worse? You know?
Yeah.
It's definitely, you can write worse code faster. I'll give you that, you know, that's for sure. Is it really allowing you to write? I think it will. I also believe it will make people faster. But how much will depend on the validity of the code. If you had a system that could guarantee you that the code is accurate, that would be like a complete revolution. This is not what it is, right? And so I think it's, again, having guarantees and having control over the output is something that's really one of the, you know, big challenge of these models, you know. Making sure that what it says is accurate. That's another thing. You know, with language model, they hallucinate. Well, avoiding that is really, really, really tricky.
Yeah, I guess going back to my earlier question, you know, we're seeing like a whole bunch of different big models coming out that all seem like functionally like transformers, you know, trained, you know, in a huge, you know, corpus at you know, basically like all text that anyone can find, as far as I can tell, and at high volume. Do you feel like the research is sort of converging on this one technique, or do you feel like, you know, DeepMind and Meta have like sort of different strategies and points of view there?
Well, actually, you should have seen Jan's Jan's tweet a few days back, and he's like, "Hey, it's weird. Nobody talks about reinforcement learning anymore." And so, which is, Jan had said, I don't remember, he said, oh, that means, we don't really need the cherry anymore. I don't know if you remember this metaphor of the cake, right? To say, okay, the cherry is the reinforcement learning, and supervised learning is the icing, and the body of the cake, right? Is unsupervised and is self-supervised. And so he really, I think, predicted that it would happen. And it is happened, which is like, and it's from an information theory perspective, makes sense. When you do reinforcement learning, you get very little information whether you're right or wrong. It's kind of like a, binary, yes, no, you are going in the right direction. With supervision, you just use, just a label. And with self-supervision, whether it's where you use the whole data. And so maximizing the information you get out of the data is definitely the trend. And I think that's where we're going. And, you see self-supervision happening every field. The flip side also is, transformers are just, working amazingly well, and scale is working amazingly well. And the combination of all this, right now it's a trend. I don't think we have like a secret sauce that would be, or we had, as no longer there, but.
Right. Interesting. Do you feel this concern that very few people will be able to do this training at large scale? Like, what do actually academic institutions do in a world where the most exciting results are coming from very, very high volume training?
Yeah, it is. It is concerning, and I can tell you that the costs of this system and these models. I mean, like just before I left, we put online like one of the biggest supercluster out there.
Yeah.
And it's just extremely expensive. Like, I can't tell you what the cost, but it's staggeringly expensive. So yes, it is worrisome, and it does work. But I do believe that we are kind of wasteful in the way we do things today. We're not really optimizing. It was very interesting to see Stable Diffusion come out really quickly after DALL-E. So I'm a huge proponent of open sourcing, of open models. I'm actually like, Meta had done it with OPT 175, but it was cool to see Stable Diffusion come out after DALL-E, but not only like releasing open source, but also shrink wrapping it. So now that I'm by myself, actually I've been running it on my own computer or on a collab, it's pretty cheap, and that's kind of cool. I'm like, well, okay, I haven't been able to train my own version yet, but at least it's a bit more manageable. But overall, I am a little worried. And I'm not seeing, how we can avoid this, given how well it works. But we also have efficiency gains we can make,
We always talk about sort of like the practical applications here and how they're different than research. Can you talk a little bit about at Meta, like what were the applications that like really mattered to Meta that they were using, and how that kind of differed from the research interests?
Let me ask you a question, because that's something I feel like,
please,
when people overbuzz AI, I ask them, it's like, okay, what did AI change in your life? I mean,
in my life?
That question? Yes, in your life. What did AI change, really, truly, something? Don't tell me like you set a timer on Alexa or Google Home. Okay, that's not life-changing. So what was life-changing that came from AI, right?
That's interesting. I mean, I feel like my life is not that different than, someone in the 80s, but by that sense, I actually love, I love listening to music with like an agent where I could just request it by saying it. It's like delightful, but I wouldn't say it's like life-changing. I mean, I assume that like all the recommendation systems that I interact with probably guide me. I mean, I feel mostly happy about that. Like I do feel like, I remember when Amazon kind of first came out with the recommendation system, it just felt so great. It was like, there's a whole world of like books that I want to read that I didn't know about. So that might be the most, I don't know. What do you think? I mean, you've probably thought about this more than me.
It's a good point. So I mean, actually, it's interesting what you say, right? So I will challenge that the first one. I mean, I don't think when people life-changing is that I can ask something from music.
Life-changing is way too strong. Yeah, yes. For sure.
But it is true. So to answer your question, you guess right, which is, at a place like Meta, recommender systems are just hugely impactful. And in two areas, one is advertisements and the other is organic recommendation. And just that, by the time I left, my team was a few thousand people and justify the entirety of the budget, by far, multiple. The ROI of investing in this system, with larger scale, especially you can imagine an advertisement, is really staggering. So if you ask me, that's actually, it's kind of disappointing if you think about it. But the most successful application of AI so far has been advertisement. And I would say maybe the second most successful has been recommender system in apps like TikTok, for example. But it's kind of behind the scenes.
But actually, you're a search guy. Don't you think maybe, I should have said search. I feel like web search is incredible.
No, because
right?
web search came out without AI, right? I mean,
That's true.
The whole history of AI at Google, I would like to be a fly on the wall there. Actually, there was a Sundar I got interviewed by Kara Swisher just recently, and he was talking about how much reluctance there was at Google to use AI in search. Actually, it's a fairly recent story, actually. And today, even some people, I do think actually AI is very useful in search, but I would put that in the category of kind of behind the scene. You don't really understand what it's doing, but it's also a late story. Whereas in recommender system and ads, I think it came much earlier as a fundamental block, whereas I think Google worked pretty well early on with traditional information retrieval techniques,
Mm-hmm.
But so you're right. If you ask me to answer your question, recommenders are the big thing. The second big thing, which is especially when I was there, was moderation. So moderation at scale can only be done with AI. So moderation at scale is done. I think you can look at the stats as a report done every 3 months, but now we are up to like high 90s, in most of the things. Even though there are 30,000 people doing manual moderation that pair with the AI, the amount of data to process is so great, right? That the majority of the first action is done by AI, in the 95% plus. For things like, hate speech or bullying or a lot of complex problems. Doesn't mean it works perfectly, but it creates enough friction that I think it does make the system overall much better.
And when you scale up to that, that massive like volume and so the massive volume of inference, like what sort of changes about how you approach a problem like that? Like say, moderation at scale of trying to moderate everything that's coming into Facebook.
I don't know if you're asking in terms of like the actual application or the support of that application, So support application is very, very hard. Like the whole MLOps aspect is just, and we could discuss that. It's really, really hard. I don't think in my tenure at Facebook Meta, we solved it. We solved some part of it, especially with PyTorch. I think it was great success, but after it's hard. So all these systems that evolve quickly at scale, very, very hard. On the other side, from a user perspective, scale is tricky because you can have the impression it works well. So all our stats show, hey, we made a lot of progress. If you look at, since we introduced AI on hate speech, the amount of hate speech in the platform went down 3x. Unfortunately, that doesn't mean that's the experience of people, and it doesn't mean it's true for anybody anywhere in the world. Very, very interesting problem. The experience, for example, is very interesting. It doesn't matter if you match your policies and you remove hate speech. What matters actually how people experience your product. And that's a very different story. And then the experience of people depends a lot from where they are in the world. And, the language aspect, the cultural aspect are very, very important there.
Mm-hmm. It's interesting that you say, actually, I was kind of curious about both sort of the technical and non-technical challenges. But, since you bring up PyTorch, I would not have thought that PyTorch was something that you think of as sort of like helping with the operations. I feel like when it came out, it seemed oriented more towards research, but I guess maybe I'm wrong there.
Oh yeah, that's a long story. So I can tell you a little bit of the story, how it happened.
Tell me the story, please. Yeah.
Yeah. So when I joined Facebook at the time, right in 2018, the company had decided to go on a dual path, with PyTorch, Café 2, and Onyx in the middle. And I thought, man, that's just such a hack. That's a non-decision. I think the decision was made 2 months before I arrived. And it's the one thing, usually when you go join a company like this, you do not want to make decisions early. But this is one decision where I told the team, actually, I didn't say, hey, we should do PyTorch. I told the team, no way we're going to do this. And from experience, I knew that we needed to be on a platform that had community support. And so I told the team, okay, you're going to have to pick one framework that we know will have traction in the community. And And they were honest, and they knew that that could not be Caffe 2 at the time. The community support there really dropped. PyTorch was a rising star, but not production ready. And really the only one that had all these aspects was TensorFlow at the time. But the team was convinced that the model, of PyTorch was better, and allowing to do more dynamic, graphs, and so they came back and say, hey, we think we can make it happen, and we can make PyTorch a contender, both on the research front and the production front, and that's where the company bet. And for the past 4 years after the decision, we've been moving almost everything at Meta from Caffe 2 to PyTorch. And people love PyTorch. So it's not actually a hard thing to convince people. It's just amazing. It's a better tool to do exploration. But it didn't mean we had all the MLOps around it. And to this day, we still are trying to really figure it out. So it's not easy, but it was the right choice. PyTorch definitely, as you sure have seen, it's a product that people love, and you want to start from that. And so that gave us a lot of traction. That's the right direction, but they still lack a lot of the infrastructure around it. And there are a lot of reasons for that, and we could discuss it.
Well, do you have a theory of why it's so loved? Because, we watched this firsthand. Like when we started Weights and Biases, TensorFlow had a clear lead, and we watched PyTorch overtake it just on our own logs. It was a really dramatic shift. And it's funny because, from my perspective, and I've like dabbled with both, they seem pretty feature comparable to me. I mean, there's sort of in the early days, there was obviously PyTorch had the, sort of just-in-time generation of the graph. But do you have a theory about why PyTorch seems like it was so much better loved?
Yeah, I mean, I'll give you another little anecdote. I remember the reason actually I felt strongly about this when I joined Meta is before I joined in my team, I remember we had also this problem at the time. You had Theano, you had like other system, and we were a small team. I was in a startup, and we were a small team, and we already had a few frameworks. I said, like, we can't do this. Okay, we got to agree on one. And so I think we agree on one. I think it was like TensorFlow. And 6 months later, they're like, no, we got to use PyTorch. Like, no way we can. And I'm like, we made the decision, and we went to PyTorch. I'm like, oh, okay, there is something there. I actually think that the reason is simple, is that the people who develop PyTorch, Thumis in particular, had a design mindset. If I were like in the design mantra, it was actually a user-centric design. Okay. And it's funny because I think the people who did it didn't necessarily know it. I'm not sure even they knew that terminology, but it really definitely had the researcher in mind and what they wanted to do. And you can feel it. The problem with TensorFlow is that it was retrofitted. So even if now, because of influence, it's there, it has been plugged on top, it still feels like it's cobbled up together. And, it's hard to acquire the love, like you can lose it. It's hard to gain, And
right.
So it's really about, user friendliness, researcher friendliness, actually. And I think also the fact that research is driving the narrative in AI today. It's not a stable field, right? And so that really put PyTorch at the center, I think, of that universe.
And so what were the important pieces that you had to put around it to make it, really work for you in a production environment? I
mean, the challenge with PyTorch, I tell you, the really complex stuff is that it's almost like an anti-pattern. And let me try to explain that. I think there's this, saying that, early optimization is the root of all evil. But the challenge with something like PyTorch is that you need to do early optimization. You don't have a way around it. Why? Because you need to create a system that gives a lot of flexibility to users to do a lot of things, yet is optimized, because scale matters, efficiency and speed matter. So you have this constant challenge of, especially in the interest of the operator internally, to have things that really follow. Like if you couldn't do transformers today, PyTorch would be awesome and everything else, forget it, right? Nobody will use it, right? So you need very quickly, when you see where the trend is going, you have to go and put very good operator, and you need to optimize it. So you have this constant, progress there doing this. That's one challenge. The other challenge is we had to give that team, and I'm really a big believer in focus. And in this case, it was a constant battle. I say, hey, look, you have to focus, and I cannot make it simpler for you, and you cannot screw it up. One is you cannot screw the external community. You have to create something that people will continue loving. and you cannot make it bloated, right? The problem when you start creating enterprise software, production software, it becomes bloated, it becomes difficult to use. You can do this. At the same time, you have to make it work for us internally. And, it has to have all the production aspect. It has to be deployable, it has to be production ready, which most people in the research community don't understand. It's actually, so we had to have these two objectives, and it's hard. The team suffered through, but I think they did actually quite an amazing job at keeping it, because ultimately Meta is going there. It will be at 100% PyTorch in a very, soon future, and I think the community still loves and adopts it.
Was there some experience that you were talking about that made you understand the value of community support? Like, were you using something at a different company where they didn't have the community support? You just mentioned that a couple of times, that it's like so essential to use technology that the community believes in.
Yeah, because I've seen companies, being stuck in a data end. I mean, actually, you could almost argue, I don't know, maybe they're going to help me for this, but PHP and hack at Facebook, is a really tricky one. They kind of own it. I mean, Facebook is so big that I guess, Meta is so big they can own it. But I really think these are not good. I think you see it dying on the vine, and you are adopting a technology that just doesn't progress anymore. And so I've seen it for many systems. I would say all I would say, like the big data systems, the containerization system, you can see there's always kind of like one winner, and if you make the wrong choice, you're kind of stuck at some point moving off from it.
Right. I thought you were going to maybe mention IBM Watson. I'm kind of curious what that experience is like.
That is a very different story, and so I can tell you more about this. I mean, I think Watson was, the good thing for me is that, I went there through an acquisition. So I had created an AI company, and IBM acquired it. It was great for everybody, so I was very happy. But actually, I think when IBM created the Watson units, that was a bold move. It was really about saying, hey, we believe there is a commercial potential in AI. That was 2013. That's not, at the time, actually, not many people were talking. We were talking about AI. The deep learning revolution came around like 2011, 2012. People were seeing it's coming. Actually, Jeopardy, the challenge, when they did it with Watson, did not use deep learning, which is kind of interesting. It's a bit of a dirty secret. It used very little machine learning. It used traditional NLP, and they managed to get something pretty good. And so, they made this big bet on it, and I think it was really, obviously the right bet. And it was early, and it was good. But there were challenges, right? The challenge is that you had to be patient. And so, I tend to say, like, you need to be impatient for profit and patient for revenue. And IBM did the opposite. They were impatient for revenue and patient for profit. I mean, they did a lot of this very large engagement promising the moon that you may spend, $10 billion to make $1 billion. That's not a very good business, And so what I was focused when I was there was really try to, shrink wrap AI and put it as cloud services. At the time we came up with this idea of like putting AI in the cloud as services to do speech, to do conversation. And to this day, I think that's still the majority of what Watson is doing. I think it was very ahead of the game, and it was, but the other problem is IBM didn't have much of a cloud, so I felt a little bit stuck when I was there, because I think it's the right strategy. I think we're getting traction, but I'm building on an infrastructure that's not as robust as if you are Amazon or Microsoft, right?
Mm-hmm. And then you went into drug discovery, didn't you? Which is super hot now, I feel like. Is that right?
Yeah. So I got recruited to be the co-CEO of a company called Benevolent AI. I think it's a fascinating field. I'm a huge believer that it will happen. And so if you can see that there's a lot of promising things happening in AI. Even at Meta, in the research team fair, we were doing things around like, understanding the function of proteins, looking at making prediction around free energy on small molecules and catalysis, like very interesting stuff you can do with AI today. Now, that said, it hasn't really completely changed the field. I actually think that drug discovery needs a bit of what I would call like a Tesla revolution, which is you need kind of a tech company to take it head on. but it has such a huge amount of domain knowledge that it's a very hard problem. It's like, similar in some way to what Elon did with Tesla. Like, it takes 15 years to understand what to build a car. And I think drug discovery is even bigger than that. It's even more complicated. But the decision process of these companies, the way they approach technology, the saying there is there's no good model out there, but some models are more useful than others. Okay, that's what they say out there. And the reason is the models are more useful is because they just use them to justify the decision they had made before. So that's the way drugs are made these days. A lot of decision made, not a lot of data to support it, a lot of influence. You have a concept called like a key opinion leader. That's how decisions are made there. I'm not a big fan. Influence authority. That's not, I think, how a business should be run. But that's how it is right now. So I'm really looking forward to a big disruption, and maybe I'll get involved in this again.
That would be cool. I mean, when we started, Weights and Biases, we didn't think that we'd have many pharma customers, and now, we work with most of them. So it does seem like, at least the pharma companies believe pretty strongly that there's something there for, deep learning, I think, to help with drug discovery. I mean, do you have a sense for like what the breakthroughs have been that have, made things like AlphaFold work well?
Well, yeah. I mean, there are different channels, but so it does. What I find remarkable is that, and I still don't quite understand it, which is, it does seem that deep learning and especially even like the transformer architecture, for example, are kind of able to understand grammar, of things, like of images, of text, but also of, like proteins, for example. So, like for example, we had a project at Meta where you just like feed hundreds of millions of proteins to a language model, and the system from there is able to predict function, pretty well, without having seen anything, like this very little supervised data. So it's something that I'm not sure I understand, because it's not like our brain understands molecules, right? So, but that means there's this kind of like generic computation that works well in so many areas, and it just still blows my mind. I understand that it can do it for language and for images, because humans can do that, but humans can't understand, can't fold molecules, understand their functions. And so why is it working? And why can you predict, like, can you do quantum calculation better with, I don't know. It's really, really interesting. So it seems to be like this thing that's generic even more than human intelligence,
Yeah, it does seem like an opportunity to do something that humans really can't do. Right.
Yeah, that's the case, yes.
Yeah.
But there are lots, so back to your question, there are actually lots, you have the chemistry, you have the biology, you have the clinical trials, you have patient data. There are actually many, many stages. There is the target identification. So for the behavioral AI, one of the big things we're doing is try to mine the literature to come up with a new graph, find new relationships, new targets. So it's very, very early in the game, okay? Then you have companies that try to figure out, okay, given a target, what are the right molecules that can affect that target? Can we do some AI-assisted chemistry there, right? And then there are people who try to understand better, like the biological aspects, like how like docking actually works, and then you have like the patient data, and you have like the imagery of the patient data, and how can you understand it? Can you deduct from there? And then you combine that with genetic information. So actually, there are really literally like, I don't know, like dozens of places where it can. In fact, I was talking to a friend of mine who just started a company to think of like how to design what I think he called it promoters. So not the piece that's active, but the thing that, like for example, in an RNA-based medication, but the thing that's going to say how much is going to be, how potent it's going to be. Like the little code that you don't pay attention to the DNA that usually tells you how much is used and how much the cell is going to be affected. And I had no idea this thing existed, but you need a code for that. It's a few hundred, amino acids there. And so actually using AI for that might be very good. And the advice I gave him is like, hey, go use Transformer. I bet you they're going to, train them on DNA and you'll figure out but I don't know. But anyway, there are a lot of aspects, of the process where it can we can have. I would say, dozens.
Mm-hmm. And it sounds like it's something that you're excited about right now and looking into.
Yes, it is. Yeah, but I really, what excites me is, how do you get? I'm convinced that you're gonna see a lot of like what we call like business processes being improved throughout the industry. I think you're gonna see it's slow, by the way. Like you're gonna see companies adopting for part of the processes, like insurance companies and banking and healthcare. Like they're gonna take little blocks. They're gonna work with these B2B companies and they're gonna adopt it. What I'm more excited with is like, how do you change entirely your field? And I think you have transportation. Obviously a lot of people are trying that, with self-driving car or other kind of self-driving, maybe that's going to come first. You have healthcare, and you have drug discovery, like payer, I think you have education as well. That could be completely transformed. But I'd love to do something that not just like, take the current companies and just like, incrementally improve them, which I think is what's going to happen naturally, but change the game. I think in drug discovery, you can change the game. You can change the decision process. You can change, so the attrition that you have right now that makes a drug cost $1 billion will be diminished by 10x,
Well, so I totally agree with you on drug discovery and, autonomous vehicles. I mean, I think, you'd be blind not to sort of see the opportunity there and the success that folks are having. But I don't actually know that I've seen a ton of success in education. This seems like it seems like education actually has like the least amount of technology inserted into it right now.
I agree with you. So it's a field I'm very interested in. I've been looking into it. And I mean, the way I put it, I actually just, I wrote a little like position document for this for me recently. And I'm like, the way I put it is that I think education is completely in the war for attention, education is completely outgunned today, So if you're a teenager, right, do you want to go to a boring lecture or you want to go on TikTok and seeing stuff by millions of creators, that really is adapted to your interest and understand what you like, what makes you, a system that gets you versus a system that's static and, the same way of educating that was, 500 years ago. So it doesn't mean there's no opportunity there. I think there are, but culturally, it's also a difficult field, right?
Mm.
But think of it, the way I put it is that look what's happening on TikTok. But actually, kids go on TikTok, like my daughters, they send me stuff like, oh, look at this guy teaches me math on TikTok. I'm like, come on, but yeah, that's entertaining. I'm sure that's the way to do it, but it shows you the potential, to make it a lot more engaging. You have to engage the user. You have to make it compelling to them. And I think there are technique and there is AI to do that. I think we understand that pretty well, actually. And so that I think is an opportunity.
Interesting.
Okay. More to come. I'm not gonna.
All right, excited to learn more about this. I'm as someone who likes to learn. I actually think I think YouTube has become such an incredible like educational resource, even on like deep technical topics. And I think the voting is surprisingly effective too. Like I would have thought that it would be hard for like really good educators to sort of like bubble up to the surface on, like very advanced topics, but it seems like it's a pretty good, I don't know. The algorithm, I guess, on YouTube is working well for me. I've been learning.
I agree.
More
and
math
and you look at, I think that's the thing that's, I'm not sure that works for younger students, but I think for adult education, I think for, high school education, a lot of them start bypassing, the traditional way and go on YouTube. But YouTube is also not an educational platform, right? So the other way to learn, like personally, I love learning through practice, right? And through exercise.
Totally.
So actually, I think people have different styles. So I have a hard time staying in front of a lecture. I love practice, and I love something that would. The frustration I have with all the education system today is that they don't start by kind of constantly evaluating you. Like, what are my gaps? What do I need to practice next? What's the optimal thing that I can do next, right? What's a lot of systems today really tell you like, what is the best next thing I can show you? That's how TikTok works, right? So what is the thing that's going to make you really, really want to come back on TikTok? I don't think education works like this today. What is the thing that's going to make me more informed and want to stay and continue that course?
Well, I hope you work on this. I'm
We'll
that
see.
sounds exciting.
You think drug discovery is complicated? Oh my God, like education is also like complicated, but it's like, that's the problem, like healthcare, education, like all these drug discovery in these complex fields that are hard to disrupt.
Right. I was wondering, like Meta has made this huge bet on, augmented reality, as far as I understand. Do you think that like machine learning has a role to play there, has caused some of the interest in like AR or VR? It's not a space that I understand super well.
So let me give you a framing for it. So the challenge with this new kind of interface, so let's say, assume, which is not a guarantee, that it's going to be a set of glasses that you put on your head, and let's say it's going to be the next platform, right? Because let's be honest, I think, like phones are an amazing invention, but they're kind of a frustrating invention, right? You have a little screen like this. I mean, like, I see yourself like always on that little screen. It's like, this is so, I think my prediction to you is like in 30 years, people will look back and say, my God, this is like the Stone Age, of interfaces. So, something is going to change it. The challenge with glasses, right, is that it's not a imperative interface. Like, I'm not typing. I'm not, like, in some way the phone is a little bit less imperative than a computer or a keyboard. That means like you're clearly telling the computer what you want. When you type the key, there's no ambiguity there. I think the touch screen was a little bit more of an implicit interface, which is like, it's not exactly sure what you're saying, and I'm going to try to make it's actually using a little bit of machine learning underneath there to figure out what you type, but it's not like groundbreaking machine learning, like to figure out like what exact word, and it's using actually some of this language model when you type on your keyword. But imagine now you have glasses, right? There's no input, so what is it? And, one of the obvious one is voice, but it's very likely that it's not going to be a lot just voice for sure. It's not going to be just voice. It's going to be kind of gesture. It's going to be motion. One thing that Meta is working on is a little bracelet there. They acquired a company that did this. I think it's very, very interesting. So you can maybe type in there or move your finger silently. There's going to be like motion. There's going to be trying to understand your intent. So the problem with glasses is you don't have a keyboard. You can't enter the information in. You can't tell a glasses what you want, but you'll need to have a rich interface that understands you. And so AI has to play a role there, and it's a very challenging role. It's like creating a contextual interface, that understands all the context around and lets you really direct the system you have on your face.
Mm-hmm. This is probably a speech interface, I'm guessing, or?
Well, speech, the problem is that, so speech is part of it, but what our guess is, is that speech may not play as big a role as you think it will.
Huh.
Because, it's like, I don't know, I mean, when can you really speak to a computer? Like, I mean, your phone, right, as Siri, right? How often do you use it? I never use it, so I don't.
Yeah,
I
never use it. Also.
Yeah, I never use it either. Because it's awkward, right? I'm in the middle here, I'm going to talk to my phone like this. So actually talking to the glasses while it's possible, and I don't know if you saw, like Meta came up with the Ray-Ban, and my team actually did the speech for it. It's nice, it works well. Mm-hmm. But actually there are not many places where you want to do this. So maybe you want to do more motion, your gestures, other things, a combination of all these things. Tap, so the interface will be a lot more complex, multimodal than we assume. It's not going to be just speech.
Interesting. Okay, another totally different question that I had that I was wondering if you had a thought on is, one thing that's been really striking is NVIDIA's like total stranglehold on the training market. I mean, there's like some stuff coming out of Google, but doesn't seem like it has tons of traction, at least in training. Do you have a sense for why that might be? It's lasted a lot longer than I would have thought. Like and there's lots of startups that compete and, people working on chips, but somehow it just doesn't seem to move.
Oh, I know. I would say I know all about it. Okay, because remember what I told you earlier, which is that these things are very expensive, right? And when you have a sole provider, it's very complicated and it's very expensive. Thankfully now the crypto market went down, and so I think it's going to be a little nicer, GPUs. But it did feel at time like a racket, like what we were paying for this GPU. But the flip side of that is NVIDIA is very good. And they're very good not just because of the GPU. So I think the GPU especially when you come from more of a PyTorch, exploration mode, it works well. It's very multi-purpose. I think it's very flexible. So that worked really well for us. But the thing also is NVIDIA got the software really, really well. They really got it right. And they work with us amazingly well. They're very competent people to create that's CUDA layer. And it's hard to replace. And I'll tell you, because man, I want it, and I throw some money at to other people to say go do it, or we'll do it for you. Just go. You got to be able to compete, But software is hard, and they are very talented, and they do a great job, and that's why I got them there. They just have the best software. They have great hardware and have the best software stack on top of it. And if you're serious, it's still the best in town. And even if you compare to the TPU, the benchmarks, are comparable, yet the GPU is way more flexible, right? So unless you have some workloads, I think it works well for ads for Google, the TPU can be competitive, but for the rest, actually, GPU is still the best game in town, and they have a great software stack on top,
You would think more specialized systems would work in more specialized cases, wouldn't you? It's kind of amazing that the flexible system also seems to function the best for almost all use cases.
Yeah, but think of this thing, the challenge we had, right? So imagine okay, you try to design a chip, and you design it when the big game in town, or CNN and ISTMs, and a lot of, in recommendation, it's a lot of sparse networks, and then you wake up 3 years later, and everything has changed, and the game has changed, Now it's transformer, and actually dense network can start to be really relevant to do also recommendation, and you design your chip, and it takes 5 years to get it out. So by the time you get it out, it's already over, which many people have done, and have done as well, and so it's very hard. It's the problem I told you. It's this early optimization, which is if you don't keep your options open while still optimizing what you have, you may be in a dead end.
Yeah. Interesting. Well, cool. We always end with 2 questions, but I guess before that, I'm kind of channeling all the students that we always get in comments, wherever we post these. I think you've had this very enviable career in machine learning, and we have so many students that use our software and watch these interviews. Do you have any advice for students coming out? What would you work on if you were just sort of entering the field out of undergrad or grad school? How would you think about that?
Well, I would not I'm not going to give you specifics, but I'll give you a little story actually that I got from a guy who used to study ants. Okay, so he just died recently, E.O. Wilson. He invented a really interesting concept around evolution, and so he wrote a little book, which is Letter to a Scientist, and he says, when I was young, I came out, and I was not even, he was in his PhD, and he decided to focus on ants. And the amazing thing is, at the time, that sounded like a very crazy idea. And obviously, ants, we know as societies are very important now. And he became the world specialist in it, and world renowned. And so what I tell people, especially in science who come out, is don't be afraid of going for something that you own, that's your own thing, and go for it. And be bold about it, And actually, don't assume that everybody has done everything. There's a lot of opportunity for you to own it and go for it and be focused on it. And so that's what I would advise. I think there's very wide space. There's a lot of space for everybody, and so be bold, be ambitious.
Fair enough. All right. Okay. So the last 2 questions are: one is, and this is it seems like you're kind of doing this, but if you had extra time to work on something, what would it be?
That's what I do now. I told you I do kite surfing.
Totally. Yeah. But if you weren't kite surfing all day long, what would you be looking into?
Well, for me, I do 2 things because, one is, I was a government manager for the past, 10 years. I think the last time I coded was before my company got acquired, and I love coding. So I'm going back to coding, I'm going back to getting my hands dirty, really understand, I as much as my team developed PyTorch, do I really understand it? Do I understand how it works? And so I spend more time, doing this, and that's a lot of fun. I think Karpathy, just coming out of Tesla, I said the same. It feels like, oh, my skin is cleaner, I sleep better, so dealing with technical problem rather than people problem is always, a big boost. So that's what I'm doing, really, really stay up to date. And actually, it's really critical to understand, my next stage is, okay, I want to write a transformer from scratch. What is that?
Nice.
So the second I'm trying to do is really try to evaluate where the big opportunity is, And I think for me, I feel like, okay, I've done the B2B startup. I don't want to do another one like this. And I want to try to see like what's going to be the big revolution here. Is it going to be like drug discovery? Is it going to be transportation? It's going to be education. So I'm going to pick one. I'm going to make a bet. I'm going to go for it. And maybe I'll fail, and maybe there's 1% chance I'll succeed, but at least it'll be worth it,
Nice. I love it. Okay. And final question is when you think about, taking a model from sort of research to like deployed in production and useful, like where do you see the major pitfalls, or where are the pitfalls that might be surprising to someone that was just a researcher?
Oh my God, it's so complicated, like it's actually really, it's something I feel like we don't figure out. I mean, I'll reverse the question, which is like, what makes, let's say, DevOps good, right? You want some things that's, reliable, that scales, that you can test. And, while, testing in AI, it's hard, actually. How do you test, actually? You can test like, tests that are very close to the model, or you have downstream tests. Imagine you change the speech recognition and you have 20 systems with 20 layers on top of that. How do you test the last system that depends on that? Reliable, well, these systems, I mean, we claim they are deterministic, but they are not, actually. A lot of behaviors are really weird, that you cannot actually completely reproduce, right? And then scale. These things keep scaling, like every year at Meta, we were like 10x bigger, and it wreaks havoc in all your assumptions. It's really, really hard. It really breaks the assumption you want to have to create this. They're just not there, and I don't think we've figured it out. I think it's still a work in progress.
Awesome. Well, thanks so much. This is super fun. I really appreciate your time. Thanks, Joe.
Thank you so much, Lukas.
If you're enjoying these interviews and you want to learn more, please click on the link to the show notes in the description, where you can find links to all the papers that are mentioned, supplemental material, and a transcription that we work really hard to produce. So check it out.